Today we'll be looking at properties of rectangles. The definition of a rectangle is a parallelogram with four right angles. So if you notice, you have here four right angles. A very important part of this definition is this part that says a parallelogram. You need to understand that a rectangle is a parallelogram. So everything that we learned about parallelograms apply to rectangles, and now we're going to even add more to it. So some properties of a rectangle is first off, four right angles like we already talked about. And second, the diagonals are congruent. So if I connect opposite angles together, these diagonals will be congruent. When we learned about parallelograms, we only learned that they bisected each other and not congruent. But for a rectangle, they will be congruent. Once again, as a reminder, because a rectangle is a parallelogram, we can say that opposite sides are parallel. So if I drew a rectangle, I know it has four right angles. I'm also going to know, because it's a parallelogram, that opposite sides are parallel. I'm going to know that opposite sides are congruent. So this side will be congruent to this side, and this side congruent to this side. I'm going to know opposite angles are congruent, which is obvious because they're both right angles here. Consecutive angles are supplementary, so they still out to 180. And finally, the diagonals are going to still cut each other in half. So when I draw my diagonals, this part will be congruent to this part, and this part to this part. And of course, the diagonals will be congruent to each other. So let's try some problems with a rectangle. We're given here, this is a rectangle. So we know lines are parallel, opposite sides are congruent, all that good stuff. And tells me this is 20 degrees. Now, this right here should be a right angle. So we know 20 degrees of it, which means angle 1 is going to be 90 minus 20, which equals 70 degrees. We also know by alternate interior angles that if this is 20 degrees, angle 2 is also 20 degrees. Therefore, this will be 70 degrees as well. Now, we have to know, now we got to figure out what angle 3 is. And this is important that you recognize this as a rectangle. Remember how the diagonals are congruent and bisect each other? That means this is congruent to this and this to this. This means you have an isosceles triangle right here, right here, right here, and right here. So if this side is congruent to this side, then this angle 70 is also congruent to 70 degrees right there. Notice those two are congruent in a triangle because the diagonals create isosceles triangles. Now, just ask yourself, what does a triangle add up to? 180. So 180 minus 70 gives you 40 degrees for angle 3. So angle 1 was 70, angle 2 was 20, and angle 3 is 40 degrees. Those isosceles triangles are very convenient to recognize in a rectangle. All right, so let's try this one. We're given that AD is 10, which means BC is also going to be 10. We're given EC is 8, which means this will be 8. And because it's a rectangle, this will be congruent. So all of DB will be 16. Now notice here, you have a right triangle because it's a 90-degree angle, because it's a rectangle. This is 10, and this is 16, 8 plus 8. So to find our missing side, DC, we just use the Pythagorean theorem. 10 squared plus x squared equals 16 squared. 100 plus x squared equals 256. Subtract the 100 from both sides, and now we're going to square root both sides. So let's break down 256. So let's see there. 4 goes into it, and 39 goes into it. Okay, so 4 is a perfect square, so we're done with that. 39 is 3 and 13. Neither of those are perfect. They're both prime, though, and they can't be broken down. So when we pull out a number, the square root of 4 is 2. And what stays inside is 3 times 13, which is 39. So DC is 2 root 39. Make sure you realize that you can use the Pythagorean theorem to find missing sides on a rectangle. All right, I want you to pause the video, fill in the information, and try to solve for the missing sides. All right, let's see how you did. AE is 5x minus 15. DE is 2x plus 6. And BC is 3x plus 3. Now remember, diagonals are congruent and bisect each other. Therefore, 5x minus 15 will be equal to 2x plus 6 because it's a rectangle. Subtract 2x. So 3x minus 15 equals 6. Add the 15 to both sides. 3x equals 21 and divide by 3, so x equals 7. So you know that AE will be 5 times 7 minus 15, which is 35 minus 15, which equals 20. You can also check and you'll see that this is 20 as well. It wants to know AC. So AC is the whole thing, so 20 and 20 is 40. And we also want to know DC. So once again, we're going to be looking at a right triangle. So this is 40. Now we know that x is 7. So 3 times 7 plus 3 gives you 24. Remember, opposite sides will be congruent. So Pythagorean theorem tells me 24 squared plus x squared equals 40 squared. Let's see, 24 squared, 576 plus x squared equals 1600. Subtract the 576, so x squared equals 1024. Square root that, you get x equals 32. Nice, perfect square. So once again, we use Pythagorean theorem to find a missing side of a rectangle. Finally, this is the last one we'll look at. Pause once again and see if you can solve this problem. Okay, angle ABE right here is 27 degrees. DB, this whole diagonal, is 17. And BC, this side is 8. So let's start with the angles. Angle DAB. Well, it's a rectangle, so it's going to be 90 degrees. Angle DBC. Well, this angle plus this angle should equal 90, so that leaves 63 degrees for this piece here. All right, so DC now. All right, we're going to have to use Pythagorean theorem, it looks, to find that. We know that DB is 17, so if you draw your triangle, 17 there, 8 there, and x here. So it's going to be x squared plus 8 squared equals 17 squared. X squared plus 64 equals 289. Subtract the 64, so x squared equals 225. And square root it, so x equals 15. So DC is 15. EC will be half of DB, so half of 17 is 8.5. So make sure you do your homework and you practice understanding that a rectangle is a parallelogram. And thank you for watching.